This is the 2013 Level 3 electricity paper. Question 3, using a capacitor and inductor, both this time to produce a burst of sound, not a spark, but anyway. A, calculate, the circuit below the speaker will produce a sound that will depend on the magnitude and frequency of the current going through it. The frequency of the supply is set to 4.5 times 10 to the 2 hertz, 450 hertz. At this frequency, the total impedance of the circuit, Z, is 93 ohms. Calculate the reactance of the capacitor at this frequency. Xc equals 1 over 2 pi or omega f, or 2 pi f, omega fc. Plug the numbers in, calculate it, and you get a particular value. B, the supply voltage leads the current. Don't forget that's important. It leads the current by an angle of theta. So let's calculate the value of theta. Let's just draw a little diagram to show that. That would be where the current is, and that's in phase with the resistance and the voltage across the resistance. We are told that it leads the supply voltage, leads the current by an angle theta. That's also the phase difference of Z, of the impedance, total impedance of the circuit. And we've just calculated the reactance of the capacitor, and because of this phase difference that they've given us, remember that the inductance, the voltage across the inductor, or the reactance of the inductor, that will lead any change, because any change produces a voltage really quickly. So that's why it jumps ahead of things, if you like. But anyway, that tells us that the reactance of the capacitor is somewhere down here, and that's been subtracted off there to produce this. And we're going to need that for the next question. So in any case, we know Z, we've got a value of Z, we've got a value of R. When we're working in the same quantities, we have to be consistent. We can't mix up Vs with I or Vs with Z and things, so we have to use consistent things. So same units for Z and for R as impedance, as ohms. It's a similar quantity, so we can calculate theta using our right angle triangle. We've got that. We don't need that, sorry. We've got our impedance, and we've got our resistance just given to us in there. Okay, anyway, and that was given to us as 93 ohms up the top there. Rambling. C, show that the reactance of the inductor at this frequency, so we're after XL, at this frequency is 98.6 ohms. Now we don't know the inductance, so we don't have that L value to be able to just do a calculation 2 pi FL, so we can't use that. What we do have, though, as I said above, we've got that phasor diagram, we've got the resistance, we've got the impedance. If we're working off of these, we've got that phase angle. Some of these things we're not going to have to use, and we've got the total quantity here, which is the sum of XL and XC, the two reactances. So that's the total reactance. You call it XT if you like. And remember that plus that we're dealing with for this XL plus XC. It's actually XL minus XC if we're dealing with absolute values. So maybe it's a better idea to just put that in there. But hopefully you can see where we're going with this. We know that XC, or let's go this way, Z is equal to the square root of that total reactance, XL minus XC, plus the resistance, and that's squared, plus the resistance squared. So we know that resistance, we know Z, so we can calculate XT from this. Once we've got the total reactance, you'd have to do the square root of Z squared minus R squared to get that, but I'm not going to do that for time's sake. Once we know XT, we can then rearrange XT equals XL minus XC. So you end up with something like 70 odd, I think, for this. We know XC is about 28, I think, based on the marking schedule, or something like that anyway. But that adds up to that 98.6, which is XL. So you have to rearrange that. Think about what I've said, it is all there. Got to move on. D. Explain what must be done to the frequency of the supply to bring the circuit to resonance. So resonance is a condition where XL equals XC. And at this stage, XL is much larger and XC is much lower. So we have to reverse that. We have to drop XL and increase XC. So if we look at the formula for XL equals 2 pi FL, L's not going to change, 2's not going to change, pi's not going to change, so we have to lower the frequency in order to get, excuse me, in order to get a drop in XL. And that's what we can see over here, the next question. The resonant frequency is 220 times 10 to the 2, which is 220 hertz, and we were previously at 450. The frequency has been lowered. By considering the resonance condition or any other method, calculate the inductance of the inductor. So once again, the resonance condition is that XL equals XC. So we can rewrite that as 2 pi FL equals 1 over 2 pi FC. And we can pretty much just rearrange this. We know the value of C, we know the value of the frequency. 2 pi and 2 pi is just 2 pi, rearrange for L. And that's one of those common questions. You might already have the rearranged version of this formula memorised. F, last part, explain how the frequency of the supply can be altered to produce a burst of sound. So you might have forgotten that the whole point of this question is to look at this short burst of sound through the speaker. So a burst of sound will come about when you have a temporary increase in current through the speaker. So we need to get a brief burst of the current. And if you remember from your theory, in terms of the current in the circuit, it's going to be maximum at that resonant frequency, which is used in the equation above there. So what you would want to do is adjust the frequency so that it passes through that F0 and produces that burst of current, which produces that burst of sound in the speaker. And there you have it. You can either increase it depending on where your starting point is, or you can decrease it through that resonant frequency.